Alright, number 3, we want to decide if the statement is true or false. Alright, and then what we're given, if Q is true, then the statement P and the quantity Q implies R implies Q is true. We want to choose what we know to be correct. Okay, so this is a compound scenario. Move this over a little bit. So what we know in this example is that Q is true. We know that's a true statement. Okay, and what we know from conditional and some of the other terms we've been over is that when we see and, okay, this symbol and, we had a statement that this is only true if both are true. Okay, so if you see this symbol and, whatever comes in front and whatever comes behind it has to be true for the statement to be true. And furthermore, we know that this whole statement, because this is one part, this has to be true given from this definition. And we also know Q, which was also given, was true, implies R, which implies Q. We know that this whole statement is true. All right. So this has to be true, and this overall statement has to be true. So the only way that this statement could be false when we have implies or the if-then is if the antecedent was true and the second part was false. That's what we got in the definition. Let me go back and point that out in the text. I know there's some big words there. Let me see if we can see it in the truth table. Right here, P implies Q is false only when the antecedent is true and the consequent is false. So that means if P, the first part is true, the second part is false. Okay, that's the only time it's false. Now, that means this overall part will be false. So the only thing that's going to make both of these true, this has to be true. Because if R was false, then this whole thing would be false, and true and false would give us false, which means that this would be false. And P and, yeah, I think we want this, we need this to be true. So if this is true, implies Q, true implies true, then the whole statement is true. So sorry, I was looking at this. This statement is true because Q is true. P implies Q is automatically true. The statement is true because Q is true. The antecedent, okay, because Q is true, the antecedent is true. We don't get the antecedent is true because Q is true. We don't get that. That's the case. The statement is false. Nope, we already know the statement is true, and these two. So the only one that agrees is statement A, because Q is true. P implies Q is automatically true. Okay, so let me show you where that comes up, because that's not the one we're actually looking at. There is a truth table here that kind of shows you some of the conditions of the truth value with conditional. Maybe I've passed it up already. Yeah, I'm not seeing it here. Okay, yeah, must be further in the beginning. But I do want you to see that part. help drive that part home. Okay. The truth table, and it kind of explains some of this up here. This is conditional. Remember, it's only false if you have the first part true and the second part false. Alright, so these are scenarios. If the consequence is true, so here, right here, what they're saying, since the consequence is true, you automatically get true, the final value. Okay, and then you have another case where the antecedent is false. If the first part is false, you automatically get a true statement. So both times it's false in the beginning, it's true, and both times it's true at the end, you get true. The only one if you have true and then false. Okay, so what this statement here is saying, the statement is true because Q is true right here, this back part. This is true. Doesn't matter what happens before the arrow. It's automatic true. So that's what that table is showing, and that's what that saying shows above.